This is not part of the official curriculum. It has nothing to do with anything. And I don't know when you're watching this, but right now there is this thing going around on social media, in particular Twitter. And that is a group of people who are trying to explain why 2 plus 2 equals 5. Now, I think the reason that they're trying to say this is lots of people know that math is hard, and it's a feeling we all get when we learn it, that lots of the rules seem really arbitrary and made up and possibly unfair. And you ask the question, well, who gets to decide what 2 plus 2 equals? And shouldn't I have a say in that? Now, I will tell you, spoiler alert, that 2 plus 2 always has been and always will be 4. Nothing is going to change that. However, some of the things they're talking about do allow us to ask what I think are interesting questions. The questions are interesting because there is more to life and more to math than just addition, subtraction, multiplication, division, and BEDMAS questions. But none of those answers will make sense unless you first understand that 2 plus 2 is equal to 4. So let's take a look at some of those examples. And I want to introduce an example that I think will make all of this make sense. Now, this is not a math question. This is a joke. This was told to me by my second year linear algebra professor. And he said, the only reason I tell this joke is because when I was taking this course in linear algebra, my professor told it to me and I thought it was funny. So now I'm telling it to you and hopefully you have a better reason. So the question goes, I have 3 cups of coffee and 36 cubes of sugar. How can you arrange it so that you use all of the cubes and put an odd number of cubes into each cup? Now, if you've never seen a question like this before, pause the video and actually try and come up with an answer. Did you do it? Okay, so if you know something about arithmetic, you know that we have a rule, which is that even numbers plus even numbers gives even numbers. Odd numbers plus odd numbers gives even numbers. Just try a couple of examples. 3 plus 7 is 10. 3 and 7 are odd. 10 is even. But an even plus an odd will give an odd. And that will also be true if you switch and you do odd plus even, because when you add, the order that you add the numbers in doesn't matter. So now if you think about our problem here for a second, an odd number plus an odd number will be an even number. An even number plus an odd number must be an odd number. So if you have 3 odd numbers, you will have an odd number. And so 36 is an even number. This question is not possible until I tell you the answer. Now the answer is, in the first cup, you put 1 cube of sugar. 1 is an odd number. In the second one, you put 1 cube of sugar, 1 is an odd number. And in the third cup, you place 34 cubes of sugar, which by all accounts is a very odd number of cubes of sugar to be putting into a cup of coffee. Okay, maybe you thought that was funny, maybe you didn't. But let me explain why this is what makes this a nice, fun riddle and possibly a funny joke, although you're probably not laughing, is the fact that I am using the word odd in 2 different ways. Now, that is totally normal. In everyday life, we have lots of words that mean different things depending on the context. So odd in math means odd numbers, 1, 3, 5, 7, da 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 da. And odd in normal life means unusual and maybe a little bit silly. So maybe unusual in a funny way. So what makes this a bad math problem is when you are doing real problem solving, you're not allowed to change the definition of a word partway through. So what makes this good because it's a joke is the fact that we're playing word games. What makes this bad math is the fact that we're playing word games. So there are lots of sort of, how should I say this, ways that we can play word games that are bad math, but are still interesting questions. So let's look at some of the ways that people are talking about online that 2 plus 2 might equal 4. So for one example, what if 2 plus 2 isn't numbers, it's rabbits. So here I'm going to have 2, for lack of a better word, boy rabbits, and we're going to be stereotypical here for a second, and so we're going to have 2 girl rabbits, and then we are going to add them together, and we're going to come back, and whatever number of rabbits we have, it's probably going to be more than 4 rabbits, right? So here's an example you would think where 2 plus 2 gives you a number bigger than 4, like 5 or 6 or 7, or knowing rabbits, 50. So yes, that's true. No one is saying that's not true. Nobody is surprised that rabbits can do things that numbers can't. Rabbits are different from numbers. For example, this is more complicated than 2 plus 2 because the 2 boy rabbits were different from the 2 girl rabbits, right? So that information was hidden. So if someone asks you to explain why 2 plus 2 is 5, you say, okay, that numbers are different from rabbits, so the extent to which 2 plus 2 can be a number that's not 4 is just saying that, well, okay, things that aren't numbers, rabbits, can do things that numbers can't do, which is, totally fine. But if you're going to be honest, you're going to say in advance, you're going to talk about rabbits. And it's not like nobody who's interested in math has ever tried to use math to model population growth. In fact, there are questions about population growth that we explore in, I think, usually grade 11. But again, none of that makes sense unless you know that 2 plus 2 is supposed to be 4, so that any other rabbits that are around must be new baby rabbits, right? We can only make sense of that because we know that 2 plus 2 is equal to 4. Now, here's another way that 2 plus 2 cannot be 4. It is called modular arithmetic. Or you can also call it clock arithmetic. Why? Because when you use it in everyday life, it happens in clocks. So when we do a clock, we only have a certain number of hours. So we start at 1, 2, 3, 4, 5, you get this. And there's a finite number of hours. And when you get to 12, you don't go to hour 13, you go back to hour number 1. So what is, let's say that I was at 10 o'clock, and I want to know what is 5 hours later. 1, 2, 3, 4, 5. That's 3 o'clock. So in clock arithmetic, 10 plus 5 is equal to 3. Now, you can understand that. That makes sense. But that's not regular numbers. And actually, we have a way of writing that. The way you write that is you say not that 10 plus 5, at least in math, when we talk, we can, we understand that the time goes around and it comes back. But you can have 10 plus 5, you say, is equivalent to 3 mod, that's mod and modular, 12. So we say we're in a system where we only have 12 numbers to work with. If we go forward, we have to loop back again to 1. And that can make sense. And actually, in addition to clocks, you use this every day because the online security, the digital security that happens whenever you use an encrypted website to send a payment. Actually, if you're in high school, you probably don't have a credit card, so you probably don't do this. Your parents do this. Sorry. But if you use a website to pay for something with a credit card, they use an encryption program to keep your credit card information safe so other people don't go take it and buy stuff with it. And part of that encryption uses modular arithmetic. So again, you can ask really interesting questions about modular arithmetic. It turns out to be really important to everyday life. But no one would, but if someone is trying to sort of sneak in and do modular arithmetic without telling you, that's a little bit dishonest. And part of what makes math fun for people who do it seriously is we love to ask what if and see if fun or interesting things happen. So when people started looking at clock arithmetic, they had no idea that a couple hundred years later, it was going to turn into the most important thing for internet security banking ever. Nobody knew that. But mathematicians just said, well, what would it be like if instead of numbers going after 12, 13, 14, 15, what if instead of the numbers keeping going, what if they loop back around? What would happen? And it turns out interesting things do happen. But, again, so how would this work? Well, let's say instead of having a clock with 12 numbers, we only had a clock that had 3 numbers on it, like this. So that would mean 2 plus 1 plus 2 would loop back around to being 1. So you would say 2 plus 2 is equivalent to 1 mod 3. And notice, because I've been more clear, more honest, I have not tried to claim that 2 plus 2 equals 1. I never tried to say that, but I can use the fact that I can play games with numbers and I can do interesting things without claiming things that aren't true. There. Now, there is one more thing that is really, really important and useful, and that has to do with uncertainty and rounding. So numbers like 2 plus 2, those are just numbers. 2 is exactly 2, no more, no less. But if you have a ruler, and that ruler has lines on it, and you are going to measure something, what is about 2 centimeters? Something like a quarter is probably about 2 centimeters. And you hold it up to the ruler, you're not going to know, is that exactly 2? Is it a smidge more than 2? Is it a smidge less than 2? At a certain point, you're going to have to make an estimation. So when people are doing measurements, so say centimeters, you have to remember that the person who made the measurement was human. And so they rounded. So when you see numbers that have measurements, really we know that 2 centimeters really means that's something in between, in a fuzzy sort of way. Well, let's say it could go down to 1.6 and it could go as high as 2.4 centimeters. That there's estimation in there. Okay. So now, what if it was on the high end, 2.4, and I put 2 quarters? Oops. So my crummy drawings. So now 2.4 is a little bit more than 2, but not quite enough that you round it up to 3. Another 2.4 is not quite enough that round it up to 3. And I could measure this, and let's see if I've actually drawn this right. 1, 2, 3, 4, 5. So it could happen that a number that rounds to 2 plus a number that rounds to 2 gives a number that rounds to 5. Okay? Now, that's possible, but what that would mean is really what we're saying is we're saying that there is no great way to write this. So 2 plus or minus 1/2 plus 2 plus or minus 1/2 can equal 4 plus or minus 1. So that means any number that could be as small as 3 and as large as 5. Okay, that makes sense. But you don't expect 2 plus 2 to be equal to 5. You really expect 2 plus 2 to be somewhere in the middle, to be close to 4. And really what that's saying is, okay, maybe my ruler is broken. Maybe I'm not holding the coins, because coins are curved, they're hard to measure. Maybe I'm not using it quite right. So seeing in real life 2 plus 2 is equal to 5 is actually, yes, it's possible, but it's a hint that something is wrong. So there you go. So just to reassure you, you've seen lots of different ways where we can kind of be clever and we can have 2 plus 2 be something other than 4, but it's not. It's only ever not 4 if somebody is making a mistake or if somebody is playing a word game to try and confuse us, neither of which is good. So, and you can find that someone is making a mistake. So let's say you're doing, you're checking on your bank balance and well, I had this much money and I put a check in because I had my job and I have this much money. I will know if there's a different amount because I can add them together. I will know if money's missing, right? So you can use the fact that 2 plus 2 is 4 to spot mistakes, to spot somebody who might be, just doing like the cups of coffee, who might be, playing, telling you a joke, which is fine. The reason this coffee thing is okay is because it's a joke. If someone was trying to tell you this in a math class, that I have found a way to put 36 cubes into 3 cups of coffee so there's an odd number, that's fine. And if this was like math class, someone would have to be honest and say, well, really, I am using, I'm going to tell you this riddle, odd number of cubes in each cup, but I'm not prepared to tell you what the definition of odd is. It would make the joke not funny, but that would be the honest way of doing it. So really, it is okay in math to ask interesting what-if questions. Real mathematicians do it all the time. The two things you're looking for is, if you ask the interesting questions, did something interesting happen? And also, did anybody find it useful for something? Right? So, we can use math to model populations, and there's a bit of uncertainty there. We can use math to measure things, and there can be uncertainty. We can use numbers in weird ways, like in this clock situation, and stumble across a new way of doing encryption. So you can do all sorts of interesting things, but what you're not allowed to do, well, and I shouldn't say you're not allowed, it's just ask interesting questions, but what you don't do is do something weird or unusual without being honest about it. You say, I am going to do this. So today I'm going to pretend that there are only 12 numbers, and so addition is just going to keep going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and see what happens. But you don't then go back to them and say that 2 plus 2 equals 1, and that's my discovery for the day. You don't go back and claim that. So as long as you're being honest about what you're doing, then weird ways of doing things. Oh, there's actually one I forgot. And that is, what if we switch to an entirely different number system? And we were talking about number system. Well, our numbers are based on the fact that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And after 9, I have no more number symbols. So what is the next number? It's a placeholder 1 that then goes back to a 0. And then this number goes 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and when I get to the end, I run out of, after 1, 9, I run out of numbers, so the 1 becomes a 2 and I loop back around to 0. So it's like the clock arithmetic, but it's with a new counter, and that's how our counting system works. Well, why are there 10 number symbols before you repeat? Why not some other number? So for example, when you work with computers, the physical components that they're made out of, you can only store information in one of two ways. They call it on or off, or 0 and 1. So if you have 0 and then 1, the next number, there is no number 2, there is no third way. So what you have to do is you have to put two of them side by side, and you put the first one as 1, and the second one is 0. And then this one bumps up to a 1, and then this one bumps over, but that one comes, so the next one is 1, 0, 0, and then 1, 0, 1, then 1, 1, 0. I think I'm getting this right. Then 1, 1, 1. Then 1, 0, 0, 0. I really hope that's right and I haven't made a mistake. If I've made a mistake, make fun of me in the comments. So that's binary. Okay? So what about on a... what you can do is you can string a bunch of 1s and 0s together. If you string 4 of them together, you can have 16 possible numbers. And that's why you see sometimes, so imagine what math would be like if you had, if you had the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not 10. And after that you had, and they call them A, B, C, D, E, and F. Because there's no other number symbols after 9. You have to do, so really, this is 11. Sorry, this is 10. This is 11. This is 12. This is 13. This is 14. This is 15. But because I have more symbols, then the next number after that is 10. Then it would go 19, 1A, 1B, 1C, 1D, and so on. So that's called hexadecimal. Okay. So what happens if we imagine a world where instead of people having 10 fingers, people only had 3 fingers? So the numbers would go 1, 2, so 0, 1, 2, and the next number would be 10, because I don't have any more numbers after 2 to use. Then 11, then 12, then 20, which, you know, feels weird to us because we've lived our whole lives having numbers that go up to 10 and then loop around and you do the tens column, carry the 1, all that stuff. But what would that mean for counting? So if I was counting 2 apples plus 2 apples, I don't know why my apples are blue, this is 4 apples, but if I change number systems, then first number, second number, third number, fourth number, the answer to this is 11. And again, there's a way of writing this. You would say 2 in a world where there are only 3 counting numbers before you loop around, plus 2 in a world where there's only 3 counting numbers gives 11 in a world. So we can do that, and we can have fun. We can have fun and play around, and computer scientists do it, and pure mathematicians do it. Have some fun. And you are allowed to do these things as long as you're honest and upfront that you're doing them. And you know, when you're writing a test, because the teacher is really looking to see whether you can articulate clearly what's going on and whether you understand. I mean, a test is not a time to play these games. If the teacher asks you, what is 2 plus 2? You say anything other than 4, they are going to say that's wrong. So by all means, have fun with this, but just and even if you never find out why they're arguing on Twitter that 2 plus 2 is equal to 4, you can rest safe knowing that you know, the basics of math are safe, and you can get back to your math homework.